Okay, so now that we've talked about factoring these polynomials, we want to solve them, right? So factoring just gives you the factors. Solving them means I need to find the zeros, the solutions, right? The x-intercepts. So step one, I got to factor this. This looks like a perfect cube to me. So I need to get on my calculator and figure out what is 216, what to the third power. And I think it's 8. Is that right? Yeah. So that's 8 to the third power. No, just kidding. I think it's 6, right? Sorry. 6 times 6 times 6 is 216. So that's the same as x to the third plus 6 to the third. So now I can factor that into x plus 6 times x squared minus 6x plus 36. And now the new step is I want to solve that and find all the solutions to that problem. So this one's the easy one, right? So if I set this equal to 0, I just get x equals -6. And that's what you probably would have told me if I asked you what's the solution to this problem. But we also have to solve this, right? And this is never going to be factorable. That's why we leave it like that when we factor it, which means that I need to do the quadratic formula. Or I could complete the square, but I'm going to do the quadratic formula because I feel like that's what you guys are going to do. So remember, ax squared plus bx plus c equals 0. So if I do the quadratic formula here, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So if I plug that in here, I get 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times 36, all over 2 times 1. And again, I highly recommend just doing this on your calculator. So I'm going to type this on my calculator and say 36 minus 4 times 36 gives me -108. So this is why that it's not a solution you normally think about, because it's going to be imaginary. And so I'm going to divide out. I want to find the perfect squares in that. And so I see all these 36s in there. I divided on my calculator by 36, and I got that this is the same as saying 6 plus or minus the square root of -36 and the square root of 3. So remember, when you break up your square roots, you have to break them up into two things that multiply to give you that. And then we can simplify this one, right? The square root of -36 is 6i. And then I have that square root of 3 left over, all over 2. And then we have that one extra step to simplify, because 2 goes into both 6 and 6, not the square root, but the numbers out here. I can break that up, and that's the same as saying 3 plus or minus 3i radical 3. So notice on this problem, I have one real solution and two complex or two imaginary solutions to this problem. Okay, so that's why we have to know how to factor these so that we can solve them. The other type that we can factor is using that factor by grouping. So remember that if you do factor by grouping, then you want to check to see that it fits quadratic form, that this x squared is half of this x to the fourth, and it is. So that means I can say that u is equal to x squared. So I could rewrite that as 4u squared minus 14u plus 12. And then I can factor that if I want. I'm going to do that in a minute, but I'm going to do the quadratic formula because I feel like that's what most of you feel more comfortable with. But notice that this isn't what x equals now, it's what u equals. So you want to be really careful. So now I'm going to say u equals -b, which would be 14, plus or minus the square root of b squared, which I don't know what 14 squared is, but I'm just going to go and write 14 squared, minus 4 times 12, all over 2 times 4. And maybe you notice I didn't make the 14 squared. That's okay, because when you squared, it's always positive, and people tend to make mistakes with their negatives, so I just always leave that off on the squared. 4 times 12. So under my square root there, that's just 4. So I get u equals 14 plus or minus the square root of 4 over 8. And the square root of 4 is just 2, right? So I want to write out my two answers. So I get u equals 14 plus 2 over 8, which is 16 over 8, or 2. And I get u equals 14 minus 2 over 8, which is 12 over 8, right? Which is, what, simplifying that, divide by 4 is 3 over 2. Is that true? Yeah. Yeah. Okay. And so then I want to work that out. So notice this is what u equals. So right now I have u equals 2 and u equals 3/2. And I have to plug back in what u was, because I don't care what u is. I care what x is, right? That's always fun to say. I don't care what u is. And that's grammatically correct to say in this problem. So if u is x squared, then I can say x squared equals 2, or x squared equals 3/2, which I'm going to change this. Instead of 3/2, I'm going to make this, like, make it a 4 in the bottom, and I'll show you why in a minute, okay? Is 6 over 4 the same as 3 over 2? It is. So I'm going to make this 6 over 4, and I'll explain why in a second. Because how am I going to solve this for x squared? I'm going to take the square root of both sides, and that would give me plus or minus the square root of 2. And the same thing on this side, if I take the square root, here's why I made it a 4 in the bottom, because when you take the square root of a fraction, you just take the square root of the top and the square root of the bottom. And if the bottom was 2, that's really ugly. But if the bottom's 4, the square root of 4 is just 2. And on the top, I can just say the square root of 6 over 2. And I promise it's the same answer. If you type in your calculator the square root of 3 over the square root of 2 and get the decimal, it's the same as this, but this just kind of looks better. And so that's why I did that. What did I forget? My plus and minus. What do you think about that? I also want to show you the factoring way, just in case you're a factoring person. So look at this. 4u squared minus 14u plus 12. I could have done this with the quadratic formula too, and I kind of just didn't realize it. What do I notice about this right away? These are all divisible by 2. So since it's an equation, I can just divide both sides by 2 here and make my numbers a lot smaller. 2u squared minus 7u plus 6. I could have done the same thing with this quadratic formula if you noticed it, and make life a little bit easier for us, but I didn't notice until now. If I was going to factor this is where I would do the rainbow method, and I would get 12 here, and I would think what multiplies to give me 12 that adds to give me 7, and that would be negative 4u minus 3u. And then I could do my factor by grouping, and I'm kind of squished here. But if I take out the 2u, I would be left with u minus 2. And over here, if I take out a negative 3, I would be left with u minus 2. So I just want to show you that you get the same answer, right? You get u minus 2 and 2u minus 3. So when you solve that, you get the same answers as if you did the quadratic formula, and you'd have to go back and substitute in. So this is where you get to decide what makes more sense to you. Do you like using the u? Do you like using factoring, or do you like using quadratic formula? Either way, it's kind of the same amount of work, in my opinion. And then the third type here is, look at this problem. This is definitely not a quadratic form problem. It's definitely not a perfect cube problem. It is just a factor by grouping problem. So I'm going to start this one, and then you're going to finish it. So notice on this, my only option here is to see if I could do factor by grouping. So on this one, could I take out an x to the 4th? And I'd be left with x squared minus 9. And again, I want that to match up. So over here, I'm just going to take out a negative 1. And that would leave me x squared minus 9. So I have x squared minus 9. Put together, what's left is x to the 4th minus 1. And I'd like you to try to solve this and look and see how many answers you get, and see if you can make a connection here. Look back at this one. How many answers did we end up on this one? Well, we ended up with plus or minus square root of 2 and plus or minus square root of 6 over 2. We ended up with 4 answers, and those are all real answers on that one. Look at the degree on this one. Look at the degree on this one and see what you can figure out. And we'll start here in